Welcome to AI Frontiers, your guide to cutting-edge machine learning research. Today, we're exploring breakthrough discoveries from June 4, 2025, featuring 63 cutting-edge papers from the computer science machine learning field. These advances span from theoretical foundations to practical applications, representing the discoveries that are shaping the future of artificial intelligence and transforming today's research into tomorrow's technologies. Picture this scenario unfolding around us every day. You're sitting in a coffee shop, and the person next to you has their writing automatically corrected by AI in real time. Across the room, someone uses a machine learning model to predict when their manufacturing equipment might fail, preventing costly breakdowns. In the corner, a researcher trains an AI system that can solve complex quantum physics problems with just a handful of examples. All of these scenarios are happening simultaneously around us, powered by the same underlying advances in machine learning. The question that connects them all is, what makes these seemingly different applications possible? Welcome to AI Frontiers, where we explore the research that defines our technological future. Today, we're examining 63 groundbreaking papers from June 4, 2025, representing the latest advances in machine learning. These aren't just academic exercises confined to research laboratories. They're the building blocks of tomorrow's AI systems, with discoveries that might genuinely surprise you. Our journey through machine learning's latest advances will reveal how theoretical breakthroughs translate into practical applications that touch every aspect of our lives. Think of machine learning research as a vast, interconnected ecosystem, much like a rainforest where different species occupy distinct niches but contribute to the overall health of the environment. Computer science machine learning, known as cs.LG in research circles, represents one of the most vibrant and rapidly evolving areas of this ecosystem. The field encompasses everything from algorithms that learn patterns in data to sophisticated reasoning systems that can work through complex problems step by step. What makes this field particularly fascinating is its interdisciplinary nature, drawing from mathematics, statistics, and cognitive science. Each discovery strengthens the whole field, creating a network of interconnected advances. Our first major theme focuses on learning with limited data, teaching machines to learn more like humans do. Few-shot learning represents a breakthrough approach where systems master complex tasks with minimal examples, similar to how we might teach a child to recognize different animals by showing them just a few pictures of each species. Meta-learning approaches are gaining prominence, allowing systems to learn how to learn more effectively. Transfer learning techniques enable knowledge gained in one domain to be applied across different areas, making efficiency the new frontier in machine learning research. These advances promise to make AI systems more practical and accessible. Our second theme centers on building robust and reliable AI systems that work effectively in real-world conditions. Adversarial robustness protects against malicious attacks, like building a house designed to withstand storms and unexpected challenges. Uncertainty quantification helps systems make better decisions by understanding the limits of their knowledge. Fairness and bias mitigation techniques ensure AI systems serve all users equitably. Trust is built through transparency and explainability, allowing users to understand how AI systems reach their conclusions. These developments are crucial for deploying AI systems in critical applications where reliability is paramount. The third major theme involves developing efficient learning architectures that accomplish more with less computational power. Neural architecture search techniques help researchers find optimal designs, like discovering the perfect recipe combination through systematic experimentation. Pruning and compression methods enable deployment on mobile devices with limited resources. Federated learning allows systems to learn across distributed networks while preserving privacy. Green AI initiatives focus on reducing environmental impact through more efficient algorithms. These efficiency improvements make advanced AI accessible to smaller organizations and reduce the environmental footprint of machine learning research. Several key findings emerge as mini-stories of discovery from today's research. Self-supervised learning methods now rival traditional supervised approaches, reducing dependence on labeled data. Transformer architectures, originally designed for language processing, excel in domains far beyond natural language. Continual learning techniques prevent catastrophic forgetting, allowing systems to learn new tasks without losing previous knowledge. Multimodal fusion enhances understanding by combining information from different sources like text, images, and audio. Perhaps most intriguingly, causal reasoning capabilities are beginning to emerge naturally in neural networks, suggesting new possibilities for AI understanding. From these 63 exceptional papers, we've selected a standout contribution that represents multiple breakthrough themes simultaneously. This paper demonstrates practical implications for real applications while maintaining strong theoretical foundations with empirical validation. The work has significant potential to influence future research directions, combining innovation with practical utility. The selection criteria focused on papers that bridge the gap between theoretical advances and real-world deployment challenges, representing the kind of research that transforms laboratory discoveries into practical technologies that benefit society. Our featured paper presents a revolutionary approach to learning efficiency through a novel architecture that combines multiple learning paradigms in an innovative way. The research achieves a significant reduction in computational requirements while maintaining accuracy and improving processing speed. This breakthrough directly addresses real-world deployment challenges that have limited AI adoption in resource-constrained environments. The work opens new research directions by demonstrating how different learning approaches can be integrated synergistically, creating systems that are both more capable and more efficient than previous approaches. The impact and applications of this research extend from theory to transformative practice in multiple domains. Immediate applications include mobile AI systems that can run sophisticated models on smartphones and tablets. The work enables edge computing deployment, bringing AI capabilities closer to users and reducing latency. By reducing computational barriers, the research makes advanced AI accessible to smaller organizations that previously couldn't afford the infrastructure requirements. Environmental benefits emerge through improved efficiency, reducing the carbon footprint of AI systems. Most importantly, this work provides a foundation for future architectural innovations that will continue pushing the boundaries of what's possible. Looking toward future directions, today's research plants seeds in fertile ground that will grow into tomorrow's breakthroughs. Integration of quantum and classical computing promises to solve problems currently beyond our reach. Neuromorphic architectures that mimic brain structures offer new approaches to efficient computation. Autonomous research systems that can improve themselves point toward AI that accelerates scientific discovery. Human-AI collaboration frameworks will enhance rather than replace human capabilities. Ethical AI development standards ensure these powerful technologies serve humanity's best interests. These directions represent the natural evolution of the themes we've explored today. In conclusion, these 63 papers represent incredible diversity in machine learning research, yet they share a common thread: making AI more capable, efficient, robust, and accessible. The themes of efficiency, robustness, and accessibility run through breakthrough after breakthrough, from coffee shop applications to quantum physics solutions. Today's research becomes tomorrow's reality through the dedicated work of researchers worldwide. This creates a call to action for all of us: stay curious, keep learning, and remain engaged with the rapid pace of AI advancement. The future is being written in research papers today, and understanding these developments helps us prepare for the transformative changes ahead. This content was created through AI synthesis using Claude Sonnet 4 from May 14, 2025, with TTS synthesis powered by Google and image generation using Grok. Human expert review and validation ensure accuracy, though we acknowledge that some oversights may exist, and references are provided for verification. This transparent approach to content creation reflects our commitment to responsible AI use while delivering cutting-edge research insights. The synthesis process itself demonstrates the collaborative potential between human expertise and AI capabilities in making complex research accessible to broader audiences. Subscribe to AI Frontiers for cutting-edge AI research updates and daily insights from machine learning papers. Join our community and be part of the technological revolution, making this channel your gateway to tomorrow's AI discoveries. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprintserver.org.